All right, guys, the answer to this warm-up is 20.9 inches. That is the arc length. Okay, peeps, I want you guys have a discussion with the people in your group. See if anyone got it. If they did, explain it. Go. Who got this one right and can walk me through it? Pedro.
Alright, so I put the arc PR is equal to 100 over 360 times 24 pi.
100 over 360 times what? 24 pi, okay? I love that, but where did 24 pi come from?
Since we have 12 inches in the radius, we can just double it.
What? What did you say? Yes, we have to double it. Why?
I don't know.
You don't know? Pedro, why?
Because the radius is half.
The radius is half the diameter, okay? So if we double the radius, we're going to get the diameter, making the diameter how many units, people? How many units, people? 24. Okay. So what'd you do from here, Pedro? Okay.
I got that, and then I multiplied by 24 pi.
Yeah, very good. So PR, guys, when you're plugging into your calculator, you should have done 100 times 24 times pi divided by 360, okay? The cool part is since all of these are multiplication or division, the order doesn't matter in which you type them into your calculator, okay? Just make sure you're dividing by 360 and multiplying all the other ones. Aurora?
So when you're doing this, you do like all the multiplication first and then you
I do all the multiplication first and then I divide at the very end, okay? Actually, would you guys like me to show you how I type it in my calculator? Okay, so yes, PEMDAS. What does the P stand for? Parentheses come first. If there's anything inside parentheses you can simplify or multiply, you do it, okay? What comes after parentheses? Exponents. What comes after exponents? Multiplication or division. Remember, those two are interchangeable. They don't really matter which one you do first or second, okay? But those come third. And what comes at the very end? Addition and subtraction, okay? We have to be proficient at that. So your answer should have been 20.9, and then it was inches. Peeps, did it tell us what to round to? Okay. What did I tell you to round to if it doesn't say in the problem? The tens place, yeah. What did I do with the 12? So it was actually 2 pi times 12, right? And Pedro just went ahead and did 2 times 12, which gave him 24. Yeah, Nick? Question, Nick? Or are you just stretching? Okay. What other questions do we have? Okay, take out your homework from 11.1. We're changing things up, guys. We are still dealing with circles, but we're not talking about the circumference anymore. We're talking about the area of a circle. What is area in general? Very good. The space inside the circle. How is area different than length? What's their differences? What are their differences? If I told you the length of this classroom is 15 meters, what would that mean? Gigi? Yeah. It's like one of the edges is 15 meters. Do you guys agree? If I told you the area of this classroom is 350 meters squared, what would that mean? The space it takes up is 350. Do you guys agree? So look at the projector, right? If I were to take a ruler and measure this side of the projector, what am I measuring? The length or the area? The length, right? Because you can measure a length with a ruler. Do you guys agree? Because it's a one-dimensional line. But if I asked you to find how much space this projector takes up, what am I asking you to find? If I ask you to find how much space this projector takes up, what am I asking you to find? The area. Because area is a spatial, it's a two-dimensional measurement, okay? So the area of a circle is going to multiply the radius by itself. And what is r times r? What is it represented by here? R squared, okay? So area equals pi times the radius squared, where r is the radius of the circle. So let's say I gave you the diameter. How could you use that diameter to help you find the area? Sophia? Excellent. You can just divide that diameter by 2 and then use the radius in the area formula, okay? Now, I want you to make a very, very strong note of what units we're going to use to measure area, right? Length is always measured in like inches, feet, meters, centimeters. Area is not. What are the units that area uses? All of those units, but just like Javansky said, squared. Because remember, how many dimensions is area? It's 2-dimensional, right? It takes up a length and it has a width. It's taking up space. So we're going to say that you can see units squared. You could see inches squared. What's another unit we may see? Meters squared. What else? Give me 2 more. Feet squared, and one other one. What? Yards. Cool. Yards squared. This is important, guys, because if you miss those units, it will be points off, okay? All right. So the second part of this lesson is a sector of a circle. So a sector of a circle is not the entire thing. It's a section or a region bounded by 2 radii and their intercepted arc of the circle, okay? So, yeah, go ahead. Back for a second. So, guys, what are the 2 radii here? Gigi? Excellent. AB and BC. And what is the arc that's created? AC. Very good. So the sector, okay, of this circle is the entire region between that arc and those 2 radii. So it's that yellow region that we just colored in, okay? That kind of like the top right corner of that circle, okay? That's a sector. Yeah, Christina? Guys, okay. Again, this formula is for the area of a circle. But when we're talking about a sector, it's not the area of the entire circle. Do you guys agree that it's less than the area of the full circle? It's not going to be the whole thing. So what we did with arcs, do you remember how we took an arc and we took a portion of the arc and we multiplied it by the circumference? We did the measure of the arc over 360, multiplied it by the circumference. We're doing the same thing for the area of a sector. Please box in that second formula. You're taking the measure of the arc that the sector creates. In this case, it's AB. And what are we putting that sector over? 360 degrees. Why 360? What's so important about 360 degrees? That's the measure of the whole circle. Do you guys agree? So we're taking a portion of the whole circle and we're multiplying it by, what's pi r squared? What does that represent? That's the area, very good, of the whole circle. So we multiply the area of the whole circle by just the piece that we want, right? Then we'll get the area of that sector of the circle, okay? And guys, this is very, very similar to the arc length formula, okay? Because we use the measure of the arc in both cases, all right? What questions do we have so far? Go ahead. That's it, guys. The rest of the lesson is just examples, okay? That is all we are learning today, all right? So take a look at our first example. We need to find the area of a circle with a radius of 4.5 meters. Please pay attention to the instructions. It wants our answer in terms of what? Pi. And then we also need to calculate the area using our calculator. So we're going to have 2 answers here. We're going to leave it in terms of pi, and then we're going to use our calculator with pi to find the answer. So let's go ahead and do it. What's the area of a circle? What's that formula? Area equals pi r squared. What do I know about my given circle? The radius, r equals 4.5 meters. So what do I do from here? You plug it in. So I'm going to get area equals pi, put the radius in parentheses, 4.5, and we're squaring it. Guys, I have a really important question for you. Are we squaring pi? No. What is the only thing that we're squaring here? 4.5. So in your calculator, make sure you are not squaring pi. You do 4.5 squared first. Why does that come first? PEMDAS, very good. Before multiplication comes exponents. So you have to evaluate that exponent of 4.5, square it. You should get 20.25, and then multiply it by pi. So I should get area equals 63.6. And then we're going to have what units? Meters squared. Why is it meters squared? Because it's an area. Okay? Now, if I put my answer like this, I would only get half credit for this question. What did I miss? Read the instructions again. What did I miss? I still need an answer in terms of pi. So go back. What was 4.5 squared before you multiplied it by pi? 20.25. So I need another answer of 20.25 with what on the end of it? Pi. This is an answer in terms of pi. That answer is still missing something. What's it missing? Meters squared. Okay? Correct. Because it asked one answer in terms of pi, and then one answer also calculate using your calculator. So it didn't say to round pi, did it? You should have used the pi button and not 3.14 in your calculator. Nick? Why do you get the second answer? Because of what's that portion of the instructions that's in parentheses. We wanted one answer where we left it in terms of pi and calculate the area using your calculator. So actually physically type in the pi button. Okay? Good questions. What other questions do we have on this example? Okay, the second one. Find the radius of a circle with an area of 176.7 square feet. How is this one different? We're finding the radius. We only know the area. Are we going to use the same equation? Yeah, we will. What's my equation? Pi r squared. But now we're going to plug in 170 or 176.7 for what? For area. So plug in 176.7 equals pi r squared. And we solve for what here? Solve for the radius. Do I take the square root now or in a little bit? In a little bit. What do I need to do before I take the square root? Isolate it. How do I isolate it? Divide by pi. So divide by pi first. What happens on the right-hand side? They cancel out. And I have r squared equals 176.7 over pi. Before you plug it into the calculator, what do I do now? Nope, don't divide. Square root both sides. Because you need to get rid of that squared on the r. Take the square root of both sides. Boom, these cancel. R is equal to, and you're going to plug into your calculator the square root of 176.7 divided by pi. And I will walk you through how you do that, okay? Let me switch over to my camera. Actually, before I do that, talk to me. What questions do we have about these steps, guys? Yeah, Pedro? So if you divide pi before you square root it, I need you to not round that answer. You need to leave it stored in your calculator, okay? Because if you round your answer, if you write like the rounded answer here, and then you take the square root of it, you're gonna round twice, and that's not good because you may be off by a decimal, okay? Good question. What other questions do we have so far? Yeah, Jaden?
What if we round it, but we use like the answer that's in the calculator?
That's fine. So if you do 176.7 divided by pi, leave the answer stored and take the square root of that. That's fine because the calculator stores all of the digits, right? But you can't physically enter all of the digits of a non-repeating decimal, okay? Shayla? Mm-hmm. All right, so let me pause the video. Units does it get? What units does it get? Square feet? Feet squared? Is this an area or a length? This is a length. Why is it a length? It's a radius. Do we measure radius and how much space it takes up? No, we measure radius with a ruler, right? It's a one-dimensional measurement. It would be 7.5 feet. What questions do we have on this example? Cool. Next one. This is a slide that was added in on accident. Cross it out. We're going to skip example 3. We're just going to do the last example and then we're done, okay? All right, so go ahead and go to example 3, the last example in your notes. It should be the last slide. We need to find 2 sectors of this circle. We need to find the area of the red sector and the area of the blue sector, okay? The area of the red one, I'm going to say that's equal to the measure of the arc of the red sector. What's the measure of the arc of the red sector? 120. How do you know it's 120? What is that angle inside called? The central angle is 120. Very good. Yeah, go ahead. So the central angle is 120. Okay. The central angle is 120, so the arc is 120. Therefore, we're going to use 120 as our numerator. What's the denominator for this fraction? 360. We're taking a piece of the whole circle. Now we multiply by what? Two pi r? No, not 2 pi r. That would have been if we wanted to find the measure of the arc. Pi r squared, aka the area of the circle, because we want to know the sector. Do you guys see the difference? It's very similar to that arc length formula, except we're using pi r squared now because we want to find the area of it, okay? What was our radius? Did it give us our radius? 14 feet. Very good. So erase the r and replace it with 14. What do I evaluate first here, guys? What comes first in the order of operations? 14 squared. So do 14 squared. Inside the parentheses, when it says P for parentheses, it's talking about inside the parentheses, is there anything to evaluate? What was the only thing inside the parentheses? 14. Is there anything to do there? No, not really, right? So you have to move on to the next one, which says exponent. So now we evaluate the exponent. 14 squared gives me 196. Now I multiply that by pi, and I multiply that by 120, and then I divide it by 360. I got 205.3. Does it tell me what to round to? Nope. So I round 205.3, round to the 10th. Let's be very cautious about the units we use here. Good, it's square feet. Why, Jasmine? It's an area, very good, okay? We just found an area of a sector. Talk to me, what questions do we have in this example? Are we all physically practicing this with our calculators and getting the 205.3? If you're not, you're only hurting yourself, guys. You have to be typing these in as we go along. Okay, last one. Let's find the area of the blue sector. How many degrees is the blue sector, and how do you know? Yes, 360 minus 120, which gives me 240 degrees. Why did we do that? Why are we able to do that? Because the whole circle is 360, right? So if we subtract the red sector's part, we get the blue sector's degrees, or its measure. So we do 240. What else do I do? Divide it by 360 and multiply it by pi r squared, which in our case is the same thing, pi times 14 squared. So you plug that into your calculator. Make sure you do 14 squared first. I got 410.5. And it was feet squared. Yeah, go ahead. Last thing I want you to notice, guys. How are those two numbers related? Pedro? They have the same radius, yep. But how specifically is 205 compared to 410? Javansky? They're both part of the whole circle. I think you just said it. One's double the other one. Why did that happen? Why was one part of the circle exactly double the size of the other part of the circle? Yep. Very good. 120 over 360 is a third, right? So it's a third of the circle versus 2/3 of the circle. One's going to be exactly half of the other one. Guys, we're done. Turn this in.